Hey, you guys. Today we are talking about energy in an ecosystem. And so before we jump into notes, I want you guys to remember a couple of things. Remember that we get two things from our food. We get, so if we have food here, remember that we get energy, and energy is the ability to do work. It is what allows you to move, to dance, to think, to, to have a dream. It provides the fuel. Remember, though, that it also provides nutrients. And so remember that nutrients are the elements. If you remember carbon, hydrogen, phosphorus, sulfur, I think I'm forgetting one. um, uh, but they are the pieces in which the energy is trapped in. So remember that we get both energy and nutrients from our food. And the fuel is what we're talking about today. We're talking about the ability to do work. Our next class, we're going to be talking about how materials or how nutrients flow through an ecosystem. But today we're talking about energy. So remember, there's two different things. And so all of the energy in an ecosystem, and you guys know this, comes from the sun. So here we have the sun, and through the process of photosynthesis, a plant or a photosynthesizer is going to trap the energy in the bonds of glucose. So remember, we said that the energy is trapped in between those nutrients. And so here, when you have all of the carbons of a sugar, the energy is trapped in there. So here is our plant. Our plant is shining. Here is our sun. Our sun is shining on our plant. And the energy from that sun is going to be trapped as chemical energy in the bonds of glucose. So that plant can use that chemical energy to fuel it, or we could eat that plant and it's going to fuel us. It's going to give us energy. And so energy is passed from one organism to another when one thing eats another. And so we can see how we can also track how nutrients are passed in a food chain, but today we're talking about energy. And so we can see how energy is passed from one organism to another in a food chain when one thing eats another. And so it all starts at the beginning with the sun. And the producers trap the energy from the sun. And then a primary consumer will eat it, and then a secondary consumer will eat the primary consumer. And that energy is going to be passed on and passed on. We're going to talk about decomposers next time. They play a very important role in food chains and in food webs. But today we're just talking about energy. And if we're talking about decomposers, that's something I would want to talk about with nutrients. But today we're talking about energy. And so remember, nutrients are recycled. They are used again and again. So here we can see that the carbon is a nutrient. Carbon, hydrogen, and oxygen is produced in photosynthesis. So the carbon is attached to hydrogen and oxygen. But then here, when we eat that carbon, hydrogen, and oxygen, C6H12O6, when we eat that glucose or we eat that sugar, we use it and we change it into carbon dioxide. So that carbon is used again and again and again. It just is attached to different things. The carbon will always remain a carbon. It never changes. It just is attached to different things. It is used again and again. It is recycled. Energy is different. Energy is converted. We use a different word. It's a similar concept, but a different concept. So it's going to take on different forms. So here we can see, let's think of a more basic example. There's going to be light energy, similar to our light energy from the sun. Light energy from this lamp is going to flash onto this solar cell. And so this energy is going to be converted, and it's going to, then it can be plugged into, or this fan can plug into it, and it'll be converted into electric energy. And then that electric energy is then going to turn this fan and create kinetic energy because the fan blades are going to move. So at every step there, the energy was converted. It changed form. It isn't recycled, it's converted because it takes on a whole different form. And so here we know that the sun light was trapped in the bonds of glucose, and we can see that all of that energy is here in the food. And then we eat that food, and then that food fuels us. We convert that energy into kinetic energy. It helps us move and go. If you put your hand on your forehead, that energy is being converted into heat through the process of cell respiration. So through the process of cell respiration, we are converting chemical energy into chemical energy and heat. And so we lose our heat. It just sort of escapes to the universe. It's kind of floating off of us. And that's going to be an important concept to remember as we move forward, so that during cell respiration, we take that energy of the food that we ate and we use it. It powers us to go, but a lot of it is just lost as heat. We have heat coming off of us, and we are not retaining it. It's not helping us move or go. We just sort of lose it as heat. So in an ecosystem, energy is converted when one organism eats another. And that is going to be shown here as energy moves up what we call a trophic pyramid. We call it a food pyramid and a trophic pyramid. And so here is a trophic pyramid. And at the very base of the trophic pyramid, you'll see that we have a large amount of producers. Remember that those are our autotrophs. Those are the things that capture energy from the sun. And so we have that taking up the most amount of room because that's what we have the most of in an ecosystem. And so here we have our, we call them primary or our first order consumers. These are the things that eat the producers. And so the energy from the producers that originally came from the sun, go up to the primary producers. But then secondary consumers or second order consumers, this says intermediate predators, don't worry about that. First order consumers or primary consumers, secondary consumers, these are going to eat the primary consumers, and there's going to be fewer of them. Notice this trend. So there's less room on this up here on the pyramid supporting. We have only 10 pounds of these secondary consumers. And here we have just 1 pound of these top predators or tertiary consumers. Tertiary means third. And so what happens here is, remember that energy is lost at every step of the pyramid. So here, think about it like this. Remember, we put our hand on our forehead, we can feel the energy leaving us. We ate our breakfast, we ate our dinner last night, and that's fueling us to go, to move, to think. However, energy is lost. Similarly to how we put fuel or gasoline into a car. And this is a very rough estimate, about 20% of that gas makes the car go, makes it move forward. However, when you put your hand on the hood of that car, you can feel the heat coming off of it after a drive. That's because that energy is being lost. A car is not an efficient converter. Neither are we. So 20% of that energy makes the car go, but 80% of that energy is lost as heat. And so if we look at our pyramid, here we have all of these producers. We have 100% of the producers. Well, the primary consumers are going to eat the producers, but energy is going to be lost at every step up. 90% of the energy is lost when one thing eats another. And so here, at this step, energy is lost. The primary consumers eat the producers, and then 90% of that is lost. So if we have 100% of the energy here, well, only 10% here. And so when a secondary consumer eats a primary consumer, once again, 90% of that energy is lost. So we can only support 1% of the biomass, that's the living mass of an ecosystem. So there's only 1% of the biomass of secondary consumers as you have of primary producers. If you look out the window, you look out and you'll see, I'm looking out the window, I see trees, I see grass, I see plants, I see a couple birds. I don't even see any secondary or tertiary consumers out my window, but I see lots of producers. And that is because we have to support all of these organisms in an ecosystem. So as the energy is passed upward, it's lost. 90% of it is lost. So remember, energy is lost during cell respiration. These penguins, these fish, go through cell respiration, and that energy is lost. It's not being passed up to the seal. The seal isn't getting any of that energy to help it grow and live and move and think. So it's not being passed up. Also, if this is easier to think about, there's going to be hair and feather and bones that the fish aren't going to eat, or the secondary consumers aren't going to eat. And so therefore, it took energy to make those hair, bones, and feathers, and those aren't going to be passed up. So that energy is lost. So here, just so that we can go over our vocab, at the base of the pyramid, we have our primary producers, or our autotrophs. And here, we have our primary consumers. You can also call those herbivores. They eat the producers. And then we have our secondary consumers. So secondary consumers are going to eat our primary consumers. And then we have tertiary consumers. And sometimes you'll have tertiary and then a top carnivore or a top predator. But then sometimes it just stops here, which leads us to our next slide. There are not usually more than 4 or 5 steps in a trophic pyramid because energy is lost at every level. If we think about this, we can see that it takes a field, let's say, for this one bunny to eat. So for one meal, it'll take about this much to feed the bunny, right? But for a week to feed this bunny, it'll take, let's say for the bunny's lifetime, it'll take this whole field to feed the bunny. But then, when this fox eats this bunny, it's going to, 90% of the energy is going to be lost. And so this bunny is going to feed the fox for just one day. And so to actually support this fox for 1 week, we're going to need 7 fields of producers, which is a lot. And so in a week, let's say that a wolf eats the fox. Let's say that it eats 2 foxes in a week. And so that's 7 times 2 times 4, that's 28, I think I did my math, 28 fields to support the wolf, because this fox is going to need to eat 14 of those fields, and this bunny is going to eat 7 of those fields. And so the amount of energy that is passed on from one step to the next is going to be lost. We're going to lose energy, and so therefore it takes a lot of biomass to feed every level up. And so we just don't have enough producers in an ecosystem to support more top predators. If you remember, if we look at the top predator, there's not a lot of space in the trophic pyramid here because we don't have enough producers to support more of these top predators. All right, so I want you to think about this, be able to answer this. Why do we have so many producers outside and so few top predators? Try and put that into words. You're going to need to do that pretty soon. Have a great day.